Today I am in Landau at Hammann GmbH, or rather Hammann Engineering GmbH, with Vincent Hammann, who is associated with the company 3 times. I would like to know what Comprex actually is, the process involved, what it entails in terms of the service provided, where the benefits lie exactly. In summary, I am seeking a comprehensive overview of Comprex, covering all aspects in one go.
Pleasure to have you here. So what exactly is Comprex and what exactly is Hammann? And it has been a total of 27 years, not a single day more, but I have not been employed with the company for that extensive duration just yet. Well, in any case, our main task is to clean piping systems. That's basically the essence of what we do. And as I mentioned, we have been doing this for 27 years. We have our own patented process, the Comprex process, with multiple patents for various applications. We started in the municipal field, meaning underground drinking water pipelines. Then at some point, we also began cleaning wastewater pressure pipelines. This is a growing field where we are usually more focused on the hygienic sector. From municipal drinking water pipes, it was a logical step to say, okay, now we are moving into smaller nominal sizes in buildings. That means warm, cold water, circulations, even heating systems. However, it must be emphasized, there we are always the very last resort in any situation. When all other efforts have failed, when dealing with Legionella or similar issues, that is the time when we step in and attempt to save the day.
It frequently operates. At present, as an amateur in the industry, I envision pipe cleaning as water being flushed through, and then it is completed, or perhaps some chemicals are introduced, and then it is completed and finished. But with you, it looks a bit different.
Exactly. So our process, the Comprex process, is based on physical effects. We don't use any chemicals. We only use compressed air and water. In the end, that means traditionally there are water flushes. That means, bluntly put, turn on the tap and let it run. Certainly consider adding a pump too. We also provide a similar option, attaching a suction pump at the rear to enhance system speed. But what we mainly do is indeed the complex process. This means in the end it's a pulse flushing process taken to the next level. So the idea of bringing together air and water in the pipeline to increase flow velocity a bit is not new. And as I said, we've been doing it for 27 years now. But the way we do it is somewhat different from what is otherwise offered in the market. That is why we also have the patents on it, and one of the benefits is that we can save large quantities of water. We can generate significantly greater forces than would be the case with a water flush.
Is there a chance of the pipe bursting, or is it currently holding up with no signs of leakage or damage?
No, it doesn't fly apart. We are still always operating under the system pressure. That means, for example, when a drinking water pipe is normally operated at around 4 or 5 bar, then we stay below that. Similarly, in the industry, which was our third field that we developed into, if there is a cooling system operating at around 6 bar, we generally do not exceed that unless agreed upon with the customer, gradually approaching it. The customer states it is acceptable. Can we increase it slightly to achieve even greater effects, where increased pressure does not always result in increased cleaning power? This is a parameter used for balancing in the end, and ultimately we remain extremely gentle throughout the entire process.
Okay. And you mentioned benefits briefly, particularly water saving. Do you have tests for that? Do you have any specific numbers on the amount of water you actually save in practice?
It always depends a bit on the application, of course, but we have numerous product tests, which we will discuss briefly later, focusing on product lines in the industry, specifically the consumer goods industry, and partly the pharmaceutical industry. In these industries, compared to traditional water flushing, which is still considered state-of-the-art, we can achieve water savings of up to 97%.
Almost ashamed to state numbers, as at first, nobody truly believes it.
Yes, that sounds wild, but it's actually true. And we don't just do this here at our test facilities and can achieve that, but we have also found that if we reach 97% here in the test facility, we still manage to achieve 90 to 93% under real conditions in the production plant. Furthermore, these are tremendous savings, which is also what is currently generating a massive new market for us, the entire topic of sustainability being a key factor in this growth. It's on everyone's lips, handling resources responsibly, saving water. Water is an incredibly precious resource, and we can make a pretty good contribution there.
Currently, we use water for cleaning with water. Usually you'd need to heat the water. To be sustainable now, that's clearly a problem.
Exactly. So even there, partially when we are in the field of drinking water, of course not underground drinking water pipes. Normally it runs through a water flush, but that reaches its limits because it simply cannot mobilize or remove as much as we can. There is no heating involved, but with numerous products, it is indeed the case that heat or temperature plays a role in the cleaning success. So there is something known as the signature circle. This is a theory that states there are 4 specific factors that are necessary in order to achieve successful cleaning. This is mechanical force on the one hand. In this case, it's us. However, at the moment, it has been very neglected because only very limited forces can be released by increasing the flow velocity. Then the factor time, the factor temperature, and the factor chemistry. And this sensory circle says nothing other than that if I increase one factor, I can reduce the others. So, in case I have ample time, I might require reduced mechanical force, fewer chemicals, lower temperature. On the other hand, if I raise the temperature, I could potentially save time using the same force and chemistry. In this case, we now reach the point where we say, or if I eliminate the chemicals, as is often the case, then I need more time, temperature, and mechanical force. I have no time and no temperature, so much power. Yes, a lot of power, and that's where we come in. We are very skilled at using the complex process to apply mechanical force to the pipeline, which is otherwise challenging. And in this way, apart from saving temperature in product systems or product lines that are being cleaned, we can also save time, which ultimately leads to increased productivity and improved operational efficiency. Additionally, in that location, there are instances where we can utilize 18 degrees cold water instead of 80 degrees hot water for cleaning purposes, providing a more flexible and energy-efficient option. This is, of course, a significant energy saving and therefore also beneficial for the sustainability efforts of companies. And quite frequently, we are able to save a substantial amount of time, usually between 60 and 80% of the total time. And when you are aware of the multitude of cleaning processes that exist in the industry, for example, which simply take up a significant amount of time, so nothing else is done in the meantime, the system just needs to be cleaned, that's also a huge advantage because less downtime means more potential, at least production time, more output, more yield.
Cool. It should touch on Complex in general again. You differentiate between services and plant construction. Maybe you can say something about that again.
From the service sector we come. That's where we started 27 years ago, as I said, in the drinking water system. And still, for municipalities, it is mainly a service. There is sometimes an application in a sewage treatment plant, where we also install a system. However, most of it is still services. And the same naturally applies to drinking water installations, meaning the water pipes in buildings, to put it simply, or heating pipes. There simply isn't the need for it to be worthwhile to install a fixed system. That means we continue to operate as a service provider. Ultimately, in the final analysis, we additionally possess a total of 25 service equipment pieces in our inventory.
Vehicles then on the way.
Exactly. That's a Sprinter with a 3.5-ton trailer. There's a compressor in there. There's a diesel unit in there. In any case, we arrive with a team that is a Sprinter plus a 3.5-ton trailer, which operates autonomously in the end. That signifies the compressor, the unit located inside, and the pressure vessel, as well as the software control, which essentially controls the impulses. We travel extensively throughout the entire Federal Republic. We are very regularly present in German-speaking countries abroad, so DACH in general, but also in various other European countries. If there's demand and the customer wants it, we'll travel anywhere in Europe to meet their needs and provide great service.
Cool. All right, we'll make separate video for attachment construction.
There is a great deal of information to share at this particular moment in time.
But I think that was already a good overview. If I'm now convinced as an industrial customer of the complex process, I would say I want to try it out. How can I gain access to that? How do I obtain your assistance in integrating into my system?
Just give us a call. So making contact is clear, logical, and then there are various options. So it always depends on the specific case and the problem the customer is facing. Either we provide a service. This typically goes hand in hand with an initial pre-planning process. One of our engineers visits the site if the system possesses a certain level of complexity. If it's just a heat exchanger or a very small, simple system, then of course you can clarify that online through a Teams meeting or something. And of course about plan work. When things get more complex, an engineer assesses the situation, documents it, then discusses with the customer on site what might need to be modified. We don't need many changes, but sometimes it simply can't be avoided. Then a report is created to ensure smooth operation when we are called into action. And then a team of technicians arrives. 1, 2, 3, 4 men, depending on what is needed. Single shift, multiple shifts, weekends, all no problem in the end. That is the way the customer needs it. That is an option if this is a one-time thing that the customer is requesting. Or a very rarely recurring story, once a year or so. And then there are various other possibilities. If it becomes a longer operation, we have the facilities behind us that are for plastic injection molding, for example, injection molding tools. If a customer wants to clean all his tools at once, it's not really economical for us to have 2 people jumping around all day. That means there is also the possibility for a customer to rent one of our more mobile devices for several weeks, for example. They will receive an introduction, then programs will be installed that are somewhat suitable for their tools, which can then be further customized, and then they can use them themselves. The devices are then returned and the customer is billed for them. After that, there are stationary systems such as the ones behind me, which come in various designs and have different hygiene standards that must be adhered to by the users. Installed in the sewage treatment plant with relatively low standards up to pharmaceutical operation. And they can also be rented for the initial test so that one can say, okay, let's see how they integrate. That is rather rare. It usually goes more like this. Product tests are conducted in our technical center and maybe also a test on site with one of our service teams. That's the advantage, that we not only do plant construction, but also services and vice versa. That means we can first conduct tests and then install a system, or a customer says, okay, I've been using the service for years, but now I want to have it in my possession and use it permanently. Then you can go the same way. In any case, a system will be installed or designed. Discussions will be held with the customer to determine the requirements, how many systems may be needed, but also what is the most economically viable approach, so that you may not need to place a system at every production line. It's simply about redundancy. Clean in parallel or sequentially, that's the decision he must make.
So you plan very concretely with the customer what is then also the most economical, right?
We attempt to locate the optimal resolution for all parties involved. Subsequently, the systems are installed and integrated. We have mobile solutions, service, and fixed integration, which also communicates with the customer's central control and is integrated into the processes. That is the preference we have, honestly, when it comes down to it in the end.
And if I ultimately decide to purchase the system permanently, would I always have to buy it, or could I opt to rent it instead on an ongoing basis?
We are relatively open. Like any company, we naturally consider what other possibilities exist. Currently, there is indeed a medium-term rental option where, for example, you could initially say, okay, I'll have it with me for a year. This is even more for the mobile units, so that the customer can try out many things, because there are indeed many fields of application. So in addition to product lines, as I mentioned, you can also work on cooling circuits, clean heat exchangers, and so on. And we've just tested with the customer again, conducted tests here, he likes it, results are satisfactory. Now they want to try it out a bit further. They are renting the system for 3 to 4 months. It will be installed there, and then a decision will be made whether we will proceed to the actual plant design. So we have some standard solutions which allow you to experiment to a certain extent. And when it comes to a very specific solution with a very, very precise or specific application profile, then we can, of course, get into fine-tuning.
All right. I believe we have successfully sorted out and resolved all the necessary aspects at this particular moment in time. It was exciting to get an overview of Comprex, and I hope it continues. Maybe you've actually heard a few new things now. I believe, even though I've been at it for so long now, yes, always something new. Very nice. Very good. Cool that you were there. Until then.